Hello and welcome back to today's session. Today, we are diving into the essential, often confused world of germ control. We are talking about sterilization and disinfection, the difference between a nuclear option and a heavy duty spring cleaning. Let's set the scene. Think of a kitchen. In this kitchen, the microbes, bacteria, viruses, and spores are like uninvited pests you need to get rid of. So, disinfection over here is like a standard pest control visit. The examiner, the disinfectant chemical, comes in, sprays the countertops, and clears off all the visible active pests the ants, the cockroaches, maybe even the mice. But what about the eggs, the larvae, or the hibernating nests deep in the walls? Disinfection doesn't always touch those. It significantly reduces the number of harmful microbes, often killing most of the actively infectious ones, but doesn't guarantee destruction of all microbial life, especially tough bacterial spores. Sterilization, on the other hand, is total fumigation. You have to move out for a few days because they are using an extreme method like gas or intense heat to guarantee the absolute 100% destruction of all forms of microbial life, including those tough as nails bacterial spores. When something is sterilized, it's not just clean, it's biologically vacant. The difference here is bacterial spore. Disinfection fights them, sterilization must destroy them. Not all cleaning is equal. Think of this as cleanliness traffic light for your kitchen tools like your knives and cutting boards. Sterilization is for critical items that enter sterile tissue or bloodstream, like a surgeon's scalpel. It needs a total fumigation, no exceptions. High-level disinfection is the yellow light. This is nearly as effective as sterilization but might fail to kill all spores. Think of a flexible endoscope used to look into your lungs. It touches the mucous membranes, so it needs a very aggressive cleaning. Almost a fumigation, but maybe a few rogue tough spores might survive. Intermediate level disinfection is like the orange light. This kills the bacteria, most viruses, and the TB bacteria, but not all spores. Think of cleaning a blood spill on a lab bench. Low-level disinfection is the red light. This kills most bacteria and some viruses, but not the tough ones like TB or spores. This is your standard household floor cleaner. So, how do we achieve that total annihilation, that guarantee of sterility? We mostly use physical methods and they involve some serious heat and pressure. So here we turn up the heat in our physical methods. Moist heat, primarily steam, is far more effective than dry heat because water conducts heat better than causes coagulation of microbial proteins faster. It's like boiling an egg. It changes the protein structure permanently. Pasteurization, it's not for sterilization, it's like a targeted cleaning for milk. You heat it just enough to kill the dangerous common pathogens like Mycobacterium tuberculosis without ruining the flavor. And boiling, it's a good disinfectant, but it's not sterilization because spores survive boiling water. Autoclave, it's pressure steam sterilization. This is a gold standard for heat stable medical instruments. It's the industrial pressure cooker. By adding pressure, typically 15 psi, we rise the temperature of the steam far above boiling, usually to 121 degrees Celsius. The superheated high-pressure steam rapidly penetrates the materials and kills even the spores. Tyndallization. This is an old, clever method for delicate materials. It's like the repeated attack. You boil the item for a short time, incubate it for a day. Let the surviving spores germinate, and then you boil it again to kill the new spore-free microbes. Repeat this 3 times. It's an effective but a slow sterilization method. So dry heat is the baking approach. Dry heat requires much higher temperatures and long exposure times than the moist heats. Hot air oven is essentially dedicated medical oven, typically for 160 degrees Celsius for 2 hours. It's used for things that cannot get wet, like powders, petroleum jelly, or sharp glass instruments. Flaming or incineration is another ultimate destruction method. You simply burn the item to ash. It's used to sterilize loops and wires in the lab or the final disposal of the contaminated material. The sieve approach, filtration. This is used for sterilizing sensitive liquids or air that would be destroyed by heat. So, membrane filters are like the ultra fine coffee filters. You push a fluid like a heat sensitive antibiotic solution through a filter with tiny spores that physically trap the bacteria, sterilizing the fluid. HEPA filters are for air sterilization. The filter fibers are arranged to trap particles, including microbes, creating a sterile environment like in an operating room or a clean air biosafety cabinet. Radiation is the energy bomb approach. This is the pre-packaged sterilization. The radiation penetrates deeply and shatters the microbe's DNA, sterilizing items like disposable plastic syringes after they have been packaged. Non-ionizing radiation, UV rays. The ionizing radiation is basically the gamma rays. Non-ionizing ones include UV rays. This is the surface sterilizer. It damages the DNA but doesn't penetrate well. It's used to reduce bacteria on surfaces in a laboratory or to treat water. So whether it's the total fumigation of autoclave or the heavy-duty counter wipe of disinfectant, knowing the difference is crucial for preventing infection and keeping our world clean. That's all the time we have for this episode of Microbiology. Join me next time. Until then, keep revising.